Welcome to an Education to Industry Experience Fireside Chat. Today, we're featuring Keegan Degoede, the combination MSU student and automotive supplier intern at Astemo. He will share how education helped translate to an industry experience and show us his Astemo final project presentation. Just to set the table, we're going to introduce the people in the Fireside Chat today. First, we have Garth Motschenbacher, the Director of Employee Engagement for the MSU College of Engineering. Welcome. Rick Currie, Senior Director, Human Capital Division and Regional Head of Talent Management at Astemo. So let's get started. Garth, what is the process for an MSU student landing an internship like the one at Astemo?
So it's really a three-step process that we look at. First, the education of the student. Make sure that they understand the opportunities that exist for their major, and then to start prepping them in terms of the documentation they'll need, resume, cover letter, how to interview, how to approach employers, do the pitch, that kind of stuff. Then we really step to the engagement piece, giving the opportunity then to meet folks like Rick, to talk to employers, to share with them their skills and interests and imagination of what they want to do. And then finally, it's that connection piece where they're actually talking now in person to someone for the company about an opportunity, about an internship, a paid experience, where they can actually take their education for a test drive and make sure it's on the right track towards a professional opportunity down the road.
Oh, that's fantastic. Rick, how did Keegan land the job with Astemo?
So I believe Keegan specifically went through Handshake, which is an interactive tool that we work with with universities to post jobs. But I think more importantly is it was part of our overall strategy, working with MSU and other partners to be able to put together meaningful internships that could attract students like Keegan. So we're thankful that he applied. And then we went through the basic interview process, liked the background. He was interested in some of the projects we were going to work on, which is equally important to what we thought. And then we decided, okay, let's give this a try for the summer.
Fantastic, fantastic. Keegan, what was your experience like at Astemo, and how did MSU prepare you?
Yeah, of course. So this past summer, I had the opportunity to be a design engineering intern at Astemo, and I think it went really well. I had the opportunity to work with some great experienced engineers, work on some awesome projects. That was really cool. I enjoyed every bit of it. And how did MSU specifically prepare me for that? Well, it's a good balance between like lectures and like different design labs. I was able to learn different skills. And then through other events like what Garth mentioned, I was able to build my resume, apply through Handshake, and it was all like a great process to find this internship.
Rick, what's the internship process look like at Astemo?
Okay, well, it starts with having our managers in different departments identify meaningful projects for the interns, right? So not only did they have to outline that project, but then they have to have the outcomes we expect for the organization, because it's a mutual beneficial relationship. And then also what the student's going to get out of it, right? What they're going to learn and what they can expect. So then we take that and we post it on Handshake. So in Keegan's situation, he applied to Handshake. We then take those resumes and we look for certain skills that match that job, right? So it's got to be in the right discipline, the type of classwork he might have done, maybe a club he belonged to or something like that. So those are the type of key things we look like. Are the external activities, past jobs that have some transferable skills are important for a lot of those positions. And then certainly one of the other things is sometimes other internships would certainly matter, right? So the academic, those type of things. So after we find that and we match that and we get that pared down to a relatively small group, I would say, we probably give the managers 10 resumes really to look at. And then they'll go through and they'll interview a number of those, and based on kind of their individual preferences as far as the project is concerned. But we try to tie the student's background as close as possible to the type of project that we have, right? And so then we do an interview. And we usually have 2 or 3 candidates come in for the interviews. And then we'll either identify them for that project, or also happens, we'll like 2 people and we'll find another project for them, or we'll put them on another internship we've already established. It's really important that people maximize the experience that they have. So you can take a job or a club that you worked in that you were the treasurer for maybe, And there's some things that are very important that people don't think about. So you manage money, right? Maybe you had to work to do some marketing that, by the way, you might think it's an engineering job, but that you have marketing backgrounds, not a bad thing, right? So people have to think in their resume how they present the things that they have done. And some of those transferable skills come out of that are really, really important. Because if you just put that, you're a student, you're only 1 or 2 years into even college, you don't have a lot to put on the resume, right? So you got to think of some of the skills you might have got even in your classes, that you did a project that might actually be related to what we're doing would be meaningful. So think about what those experiences that you've had in your life really are, and then articulate them on your resume.
I'd like to put an explanation point on what Rick just said. Never did he mention grade point average. All right. Now, that's a level that Keegan has to meet, and all students do. But all the things Rick talked about were experiences and skill sets and leadership and all that kind of stuff. And I think students sometimes overplay the GPA and underplay all the things that Rick just mentioned. And I think that's a great point that he made.
Yep. And he's absolutely right. It's not that we don't consider grade point, but it is the last thing we really worry about. It really is.
That's really good to know. I think it'll be very inspiring for people to listen to that, and also valuable to know that they need to work on that experience side of things to make sure that they have the experiential learning.
So if I have a student who worked through college and has gained some experience managing, both a restaurant or even working as a waiter or something like that, and their resume is grade point is a little subpar. So maybe that's a 2.8 or something like that, which isn't disastrous, right? I'm not going to take that person. But if they've had other life experiences that show me that, hey, look, you're out there living life and you went out there and you did certain things and you helped pay your way through school, that tells me something about you as a person, right? So there's always reasons, we look at it, but it's always reasons why it matters or doesn't.
Oh, that's beautiful. That's beautiful. Yeah. It sounds like an awesome experience to get someone, from student to industry. Keegan, we want you to share your final presentation summary.
This past summer, I had the opportunity to be a design engineering intern at Astemo, and today I'll be sharing a little bit about my internship. Autonomous driving is becoming a huge part of our society, so the objective of my internship was to study this autonomous driving technology, specifically for urban scenarios. So as I just mentioned, the market size for autonomous driving is expected to grow to over $400 billion by 2035. So this field is a very large field and it's going to continue to grow. And with that, autonomous driving in urban scenarios has made significant progress. With that being said, there remains many challenges with autonomous driving to realize it to a higher automation level. For example, there's much progress needed for areas such as roundabouts, construction zones, and highway merging. So in order to actually realize this higher automation level, there are certain challenges such as in obtaining a higher accuracy in vehicle and pedestrian detection. This is very crucial. And with that being said, it's also very crucial to ensure the safety at the intersection and these roundabout scenarios. So much of my internship was highlighting these different challenges, and what I was tasked to do was to engineer a LiDAR configuration on our test vehicle and actually implement a LiDAR perception detection so we can work to research and learn more about these challenges to find a proper solution. So as I just mentioned, my main task for my internship was to create a LiDAR configuration for our test vehicle that allowed us to collect data. And the main part of this step was to actually determine where to position our LiDAR sensors on our test vehicle. And these LiDAR sensors are very important because they allow us to collect data. What they essentially are is sensors like light radar sensors. So they're shooting different beams, and what tracks how far the beam is, and when the beam returns, it allows you to measure a distance. So we had a couple of these sensors, and my goal was to find the correct location without the car around the car. We only had a limited number of sensors, so my goal was to find appropriate locations on the car for us to collect as much data as possible. To do this, we set out different goals for myself. And one of the main goals was that we needed to realize LiDAR coverage from a distance of a minimum of 2 meters to a maximum of 200 meters. So I had to take into account that we were going to have this large span that we needed to collect data for. And to meet this goal, I used the equation of having a field of view beam angle equals to arctan min distance over the sensor height.
And that allowed me to calculate the specific distance that these sensors needed to be at. So there were a few limitations with this design. Given the fact that the sensor needed a minimum angle to actually obtain data, we were limited to detecting pedestrians less than 2 meters. We were unable to do that, just given the minimum angle, as I just mentioned. So after the field of view angle and the sensor location was determined using the equations I just mentioned, the next step was to actually implement the sensors onto the vehicle. And this required designing mounting plates to install the actual LiDAR vehicles onto our test vehicle. We were unable to directly implement the sensors onto the vehicle, so a mounting plate was required as a middle step to connect the sensor to the mounting plate and then connect the mounting plate to a vehicle. So after I determined the angles, my next step was to design these mounting plates for appropriate length and width so that it'll fit on the roof rack of our test vehicle and allow us to complete the whole implementation system so we could go out and collect our LiDAR data. After this data collection system was fully implemented, it was time to actually go out and collect the data. And this meant going out on the road and driving around using the sensors to collect data in the different scenarios. And this data was going to be used to understand the challenges for detecting pedestrians. And after our data was collected, it was time to analyze the data to see how accurately these sensors could observe the pedestrians. And to do this, I was tasked with choosing between two state-of-the-art LiDAR perception algorithms. And the first one was the Centerpoint 3D, and this was a perception algorithm. And my first step in determining which one to use was utilizing a new scenes data set to verify the vehicle detection. So online, I downloaded the algorithm. I used this new scenes data set to test the accuracy of Centerpoint 3D before I used it on my own data. And the accuracy on the new scenes data set was around 58%, which is the mean average position. And this is not very accurate. And there's some other issues with Centerpoint that were beyond the scope of my internship, but we decided to go with a different LiDAR perception algorithm, which is YOLO V5. This was simpler to use and it had a higher accuracy. So after deciding to go with YOLO V5, I used the model, I used the pre-trained YOLO V5 model to detect pedestrians on my recorded Alstar LiDAR data. So the data that I just mentioned I collected, I uploaded it and I was able to utilize the pre-trained model. And then with that being said, because there's a pre-trained model, there is original issues with the pre-trained model, such as the overall accuracy of the system was not very high. So as I just mentioned, there was an issue with the pre-trained model, and the main issue was that the pre-trained model was trained on an RGB red, green, blue image compared to the actual point cloud data that the Ouster data, the LiDAR data has. So, and this is because point cloud data, the sensor data is a bunch of little dots from the LiDAR sensor, and the data is very sparse, so it doesn't exactly transition the same from an RGB image, which explains the poor accuracy that I initially obtained with the pre-trained model. So the next step to this was to actually train the YOLO model using my data. That way, the YOLO could learn from the data and it understand what to observe next time. So this could be broken down into a few different steps. The first step was to take my recorded video, upload it into YOLO, and then I was able to extract my video, my Ouster sensor data into a bunch of different pictures because what I uploaded was a video of me driving down the road. The next step was to extract those into a bunch of different frames, and then you have a bunch of different frames. And the next step was to annotate each image using an online software named RoboFlow. This just allows you to annotate each picture and essentially put a box around what you want your model to look for. So in my case, I'm obtaining pedestrian data. So I had to go by each frame by frame and put a box around each pedestrian to teach my model that, hey, this is a pedestrian and this is what I want to observe. So once the annotation was done with using RoboFlow, I was able to upload it to YOLO, and then the model could actually learn from it and then use it in the future to observe the correct things. After the model training was conducted, the pedestrian accuracy significantly improved. For example, as you can see in the bottom left corner, I had a total training frames of 2057. Then there's validation frames of 323. and then 173 test frames. And on these 173 test frames, we actually had an accuracy of 96%, which is significantly higher than the original 50% detected with the pre-trained model. So after the model training was complete, the next step was to verify the results to verify that the model was actually detecting pedestrians at a higher rate. So to do this, the next step was to recollect data in both the stationary and moving environment, and to upload the updated model to detect the accuracy of the pedestrians. And it was actually confirmed that the model could detect the pedestrians higher in both the stationary and moving scenario. So once this model training was complete, the next step was to actually verify the results to see if my model actually did have a higher accuracy. So to accomplish this, the next step was to collect more data in both the stationary and moving environment with my test vehicle and upload the updated model on it. And it was actually confirmed that the performance in the stationary and moving environments was significantly higher than using the pre-trained model. So now I wanted to quick summarize the conclusions and future work of my internship. Given that it was an internship, I was only there for a limited time and I could only contribute so much to my project. But the first thing I did in my internship was design and implement a data collection system. Second thing I did was train a state-of-the-art LiDAR perception algorithm for pedestrian detection. And then finally, I utilized this collected data to verify the pedestrian detection in both the stationary and moving environment. And there's still multiple next steps with this project. With that being said, the first next step for someone to continue on this project would be to develop the actual simulation framework for evaluating the perception system. And then next, you could use that simulation framework to identify additional issues or edge scenarios within the moving and stationary environment. Throughout my internship, I had the opportunity to learn many lessons, not just technical lessons, but also people skills. And one of these biggest skills that I learned was collaboration. I understood the value of the effective communication, actually having conversations with these engineers, like hearing them out, hearing their advice was very important. And I embraced and applied the feedback / constructive criticism to my work that allowed me to improve my design for the data collection method. It just really helped me throughout my internship. And additionally, I learned skills and adaptability. Flexibility and creativity are essential when encountering unexpected challenges. Not everything goes planned at first, so you have to be able to adapt. And that was one thing that I really found was crucial to be successful. And finally, attention to detail is huge. You got to be precise and you have to be thorough. You got to review your work to ensure accuracy in your system and minimize errors. So as I just mentioned, I learned many lessons, but I really enjoyed my internship. It was a great experience for me. On a technical level, the thing I enjoyed most about my experience was the actual data collection. It was fun to go out and actually collect the data. You design a system, I calculated the angles, I implemented the sensors, and now I actually got to go test my system to see how successful it was. So as I just mentioned, the best part was experience the direct implementation of my work through the real world application. So on a more personal level, I really enjoyed the collaboration aspect of my internship. I appreciated the opportunity to collaborate with knowledgeable and supportive engineers. All of their feedback was very insightful and it really allowed me to learn a lot. Like I just mentioned, I valued the guidance I received from them. And finally, I just enjoyed connecting with them on building with connections on my team on a more personal level. Everyone I worked with was great. It was a great time to get to know them and learn as much as I could from them in my limited time here.
Well, Keegan, thank you so much. We just appreciate kind of focusing on what you're doing. Again, everyone, we want to thank you for listening to Education to Industry Experience Fireside Chat. Thank you, everybody. Thank you, panelists.